Oh, for this one, what we'll do is, to start with, we'll write this as and then we'll multiply this whole by this, which gives us e to the power beta x dy plus beta y dx equals to cos alpha x dx. So this becomes dy e to the power beta x equals to which gives me we can evaluate this integral. It's a standard integral. Think it is beta e to the power of beta x cos alpha x on alpha square plus beta square. Yeah. So we get y equals to c e to the power of minus beta x plus beta cos alpha x plus alpha sin alpha x on alpha square plus beta square. And by y0 equals to 0, we get the value of c, and eventually we get y equals to beta cos alpha x plus alpha sin alpha x minus beta x minus beta upon alpha square plus beta square. And substituting this y here in this equation, or in this equation rather, we get dy by dx is to cos alpha x minus beta square cos alpha x plus alpha beta sin alpha x minus beta square e to the power minus beta x square plus beta square, which is equals to beta square e to the power of minus beta x plus alpha square cos alpha x beta sin alpha x upon alpha square plus beta square. So we have dy by dx with us. Now what we'll do is, we have y equals to, we'll write this as under root alpha square plus beta square times cos alpha x plus theta, such that cos theta is beta and sin theta is minus alpha. Okay, minus beta e to the power of minus beta x upon square plus beta square. Now note that this numerator, when x is sufficiently large such that e to the power minus beta x becomes smaller than root alpha square plus beta square upon beta, then what we'll have is, so we'll have y equals to alpha square plus beta square into cos plus theta minus beta upon root beta square e to the power of minus beta x. So when x is sufficiently large, this thing will become smaller than 1, such that we'll have multiple solutions of cos alpha x plus theta equals to something from 0 to 1. In each interval of 0 to 2 pi, in each interval of 2 pi, we'll have solution for this equation. We'll have this, so this thing will be 0 multiple times. So the line y equals to 0 will intersect, or rather there will be infinitely many roots of this equation, which is y equals to 0 will have infinitely many solutions. So C option becomes correct. D is incorrect because this function is obviously not periodic, and as we have infinitely many solutions from y equals to 0, then obviously y cannot be an increasing or decreasing function. So the correct answer is C. So the argument here is, when x is sufficiently large, this thing will be less than 1, and when this thing is less than 1, we will have many solutions with cos alpha x plus theta. So for reference, so like this is something like this, and this graph is something like this, so we'll have many solutions. So yeah, so y equals to, so in option C, beta equals to 0 will satisfy the option. Y is not a periodic function, and it's clearly neither an increasing or nor a decreasing function, as there are many solutions for y equals to 0.